Hey everyone, and welcome to this explainer. Let's just jump right in, shall we? Today, we're taking a really deep dive into what our source materials call the digital trap. We're going to unpack some absolutely fascinating forensic analysis that suggests the tech industry has been using, frankly, brilliant marketing misdirections to hide the true physical cause of digital eye strain. We're talking the science, the math, and the biology of why looking at your screens might be causing you so much fatigue.
So I want to start with a question, and it's a bit provocative. Is digital eye strain actually your fault? Or, as the research we're looking at today argues, is the screen you're staring at right now fundamentally, physically defective? Because for years, the industry narrative has quietly placed the blame on our habits. We stare too long, we don't blink enough, but the data we're about to explore flips that completely upside down.
Look, since 2020, digital eye strain has reached absolute epidemic levels. We all feel it, right? But how did the display industry respond? Well, instead of fixing the screens themselves, our sources argue that they pushed behavioral band-aids, things like screen time limits, reminders to blink more, or buying yellow glasses. The analysis we're breaking down today labels these as mere placebos. They deliberately ignore a physical root cause that's hidden right inside the screen itself.
The forensic dossier we're looking at actually categorizes these misdirections into two massive industry myths. They label them lie C12 and lie C13. Lie C12 is the prevailing narrative that blue light is the enemy, and lie C13 is that constant advice you hear to just use the 20-20-20 rule. According to the research, these aren't real cures. They are calculated distractions.
Okay, let's start with lie C13. This is the famous 20-20-20 rule. You know the one, right? Every 20 minutes, look at something 20 feet away for 20 seconds. Well, the analysis starkly contrasts this myth with physical reality. Telling users to just take a break is a behavioral placebo. The reality, the sources argue, is a severely defective subpixel hardware design. Taking a break from a defective device doesn't magically fix the device. It's just temporarily pausing the harm. You wouldn't try to fix a broken chair by standing up every 20 minutes, right?
The documents go so far as to call these placebos pedagogical misdirections. It's a fancy way of saying that by telling you to change your habits, the industry successfully shifts the responsibility onto you, the biological victim. Meanwhile, the actual hardware, the physical screen emitting the light, completely avoids scrutiny and just continues to cause harm. It's what the authors very simply call victim blaming.
And that brings us to the other major distraction, lie C12, blue light. The industry, as you know, hyper-focuses on the blue wavelength. But our sources, they assert it's just a massive red herring. By blaming blue light, companies can very easily sell you filter accessories, glasses, screen protectors, software night modes, all while completely diverting your attention away from a much, much bigger, unfixable structural hazard built right into the screen subpixels.
So why is blue light such a perfect diversion? Well, because it's visible. That makes it a super easy scapegoat for a commercial upsell. But the physical reality is that intense microglare exists across all subpixel colors. Red and green subpixels produce this exact same peak glare. Therefore, slapping a blue light filter on your screen is literally useless against the underlying structural flaw, a flaw that mimics UV pulses and triggers constant involuntary squinting. Okay, so if blue light isn't the real problem, what is? Well, the source documents claim that the display industry relies on a deeply misleading mathematical metric to hide the true damage happening to your eyes. Get ready, because we are about to reveal the absolute smoking gun of this entire investigation. Here is the math they really don't want you to see. It's called the subpixel glare X-factor theory. The equation is simple. L peak equals X times L av. To put that in plain English, because modern screen pixels are made up of tiny, separated color dots called subpixels, those tiny emitters have to be wildly overdriven to massive peak energy levels. That's your L peak. And they do this just to create a normal average brightness, your L av, across the whole screen. And here is the truly shocking number that the analysis reveals. In almost all modern display devices, this X factor is greater than 3. What does that actually mean? It means that at a microscopic level, the peak glare shooting out of those tiny subpixels is at least 3 times stronger than the average screen brightness your brain actually perceives. So here is the exact trap. Industry standards measure average brightness. They assume light is softly and uniformly distributed. Sounds safe, right? But the physical reality is the X factor. The microscopic structure actually forces light into highly concentrated energy needles. The soft average brightness you think you're looking at completely masks these high-energy spikes. Now you might be wondering, what about the biological impact? Why doesn't your eye just protect you? It comes down to what the sources call the pupil's failure. Your pupil is designed to constrict in bright light to protect the retina, right? But it only reacts to low average light because the screen overall looks generally dim. Your pupil is tricked into staying wide open. It completely fails to detect the microscopic, intense peak spikes, leaving your retina entirely defenseless. The sources actually call this the anatomy of an assault. Because your pupil is tricked into staying wide open, these narrow, spatially discrete subpixel beams, these microscopic energy needles, bypass your natural defenses completely. They strike tiny, specific clusters of your photoreceptors with intense, unfiltered force. Think of it exactly like a kid with a magnifying glass focusing sunlight on a leaf. First, the subpixels take up a tiny, tiny fraction of the screen. Second, the hardware wildly overdrives them to look bright enough. Third, your pupil stays wide open. And fourth, the result is exactly like that magnifying glass focusing sunlight into a single burning point. The concentrated energy effectively burns the retina, which causes the severe fatigue we all feel. So all this sounds pretty bad. Is there an alternative? Actually, yes. While the dangerous subpixel rendering standard operates at a hazardous X factor greater than 3, a safer baseline exists. It's called real color pixel architecture. With this, peak luminance naturally matches average luminance. It operates at an X factor of basically 1, making it safe, comfortable, and fundamentally glare-free. But a real-world device audit reveals something deeply, deeply frustrating. Even the absolute most expensive flagship 2025 and 2026 devices from major manufacturers, we're talking your high-end iPhones, Galaxy Ultras, premium OLED TVs, they overwhelmingly operate at a dangerous X factor of 3 or higher. Some are even pushing past 4. The hazard, as the source states, is literally in your pocket right now. And the truly frustrating part of all this? A solution already exists. Instead of current harsh glare subpixel arrays, the documents point to a patented hardware solution, specifically patent US 9310051B2, that eliminates this native flaw entirely. It produces a soft, even light. The technology to fix this is literally already here. Which brings us to a fundamental concept raised by the researchers: the principle of non-maleficence in ergonomics. The idea that technology should not cause harm when safer alternatives exist. The authors of this forensic analysis argue that the industry's continued use of subpixel arrays while pushing placebo band-aids like blue light filters and the 20-20-20 rule represents a conscious failure of ergonomic responsibility. So, the absolutely crucial point we are left with today is this. Now that you understand the math behind the subpixel glare X factor, and now that you know blue light filters and taking screen breaks are just treating the symptoms of defective hardware, will you continue to accept placebo band-aids? Or will you demand true hardware reform at an eyes-first standard? It's a fascinating, kind of scary perspective to consider the next time you unlock your phone. Thanks for joining me on this explainer, and definitely keep questioning what's right in front of your eyes.